jumps around a lot, but it does make an interesting point. So what is the rate of change? Comparing growths in tables and graphs. So far in this chapter, you've looked at several types of sequences and compared linear and exponential graph patterns in situations, tables, and graphs. In this lesson, you will compare patterns of growth rates to each other. So this work will also help you write equations for exponential sequences in the next lesson. So we're given these three patterns, and we're asked to go and graph them on a sheet of paper. And it wants us to kind of keep out a couple things in mind. How do the inputs and outputs of the sequence increase? How does the sequence grow? How is it changing? If we knew a specific term, how would we determine the next term? For if we knew the 10th term, how would we get the 11th? And which family of functions best models each sequence? So we're going to keep that in mind as we jump over and open that up and get this graph done. So we're going to go here, and we are going to open up 531. Okay, this one. So I've taken the liberty of jotting down the numbers. So the first one, I guess I'll use black for, and the first number in the sequence was 27. The second number in the sequence was 54. The third number in the sequence was 81. And the fourth number in the sequence was 108. So something like that. All right, now we'll switch colors and we will do, I don't know, maybe I should say that's pattern A. So let's change colors and do pattern B. Pattern B was started at 9, and then it jumps to 36. It jumps again to 81. And then it jumps to 144. And then finally, that was pattern B. And finally, pattern C started at 6. It jumps to 12, 24, and 48. So I think they told us to connect these points, even like kind of make a line out of it, even if it didn't completely, these should be discrete, but we can get a feel for kind of what these charts actually look like. And that looks amazing. Well done. So, long story short, we get something that roughly looks like this. You can see that A should be linear, B and C appear to be curved. So how are these things growing? Well, it looks like A is growing by adding 27 each time. It looks like B is growing kind of weird. It goes from 9 to 36 to 81 to 144. Actually, I will show you kind of what's going on there, so you can see that, because it is a little unusual, but it's 9, 36, 81, and 144. And what we're looking for is the change. So the change here is 27, change here is 45, the change here is 63. So it's not a common change, but on the second level, it is a common change. That means that we have a square. That means it's something to the second power. If it's equal on the second level. If it was equal on the third level, it would have been a cube, which is kind of interesting. Anyway, C, it looks like C is doubling each time, so that is going to be how that one changes. So just kind of running through there. Now we will pull up the next document. Like I said, there's a lot of jumping around in this lesson, so I hope you're staying with me. So kind of like if we wanted the 11th term, we would take the 10th term and add 27 to get A on B. It's kind of weird. We're still kind of undetermined, but we know something would get squared. And on the C, we would just double it and we would get that. So which sequence do they belong in? A appears to be arithmetic, B appears to be other, and C appears to be geometric. So I hope you're with me on that. Arithmetic is adding 27. A is adding 27, so it's arithmetic. B is some sort of a square, so it's other. And C is multiplying by 2, so it's geometric. So Now it says growth rates and sequences. For each part below, consider how fast each of the sequences in problem 583 is growing by looking at the tables and graphs. Don't make any additional computations. Instead, make conjectures or guesses based on the tables and graphs. So if n represents the number of years and t of n represents the amount of money in your savings account, which would you rather have, A, B, or C? Well, I'm guessing a lot of people probably pick B, right? It's definitely curving the most and it's definitely winning. So I don't know. I mean, I hope you didn't pick A because it had already got passed by B. Will C eventually catch B? I don't know, but I know A won't. Would your answer change if you kept the account for many years? It might not. Again, I don't know what conjectures or guessing you're making. I know the answer, so it doesn't really make sense for me to say it. It says obtain lesson 531 resource page from your teacher. Extend the tables to n of 7. B is done for you. So again, we're going to kind of go here, get out of this, reopen this. And we need this page. And they want us to go to 7. And again, they told us to extend it. I guess if we look here, they've already done sequence B for us. Because it's a square, like I told you, there's a square on that one. That was why they did us that favor. So 5 would be 225. So 5 is 225, something like that. 6 is 324. So 6 is 324. So I don't know, something there. And 7 is going to be 441. So I don't know. It wouldn't really fit, but we'll say 7 is 441. And this was for sequence B. I apologize if I change colors on you. I think sequence B was like that blue color in the last one, but whatever, we'll be fine. All right, so now we'll go down and we'll do A. We're just going to add 27 each time. So 135, 45, 55, 62, 69, 79, 89. So A, we just keep adding 27. So 35, 62, and 89, something like that. So there's our sequence A, you can see. And now let's figure out our sequence C. Doubles to 96, doubles to 192, and doubles to, what, to 400 minus 16, so 386. So 5 was 96. 6 was 192. And 7 is 386. So I will say something like that. And that was C. So something interesting is going on here where definitely B is still ahead after 7. But do you think B is going to be ahead after 8? It definitely looks like B is catching... I'm sorry, it definitely looks like C is catching B, right? For sure it seems to be the case here. You can see that this one increased by, what, 117 from 6 to 7? But this one increased by 86, 194. So the jump from 6 to 7, you can see C is really closing the gap, and I would expect that that gap would probably get changed in C. So the question is, what is happening? Well, I told you that this was some sort of an x squared, right? This is like you take whatever x is and square it to get a number, and we could figure out what the equation is, honestly. I don't know, is it times 9? Is it 9x squared maybe? So that looks like it might be it, right? If I plug 1 in, I get 1 times 9. If I plug 2, if I plug 3, 3 times 3 is 9, times 9 is 81. If I plug 4 in, 4 times 4 is 16, times 9 is 144. So this equation is y equals 9x squared. This equation is y equals 27x, right? Plus 0. But you'll notice that x is to the first power. Okay? This equation, I know you guys don't really know this yet, But this equation is y equals 3 times 2 to the x. And we'll talk about this more later. But here's what's really crucial about this. Look at this exponent. The exponent here is 1. The exponent here is 2. And the exponent here is x, meaning as big as I get x here, that's what the exponent is going to be. So if I want to plug in a billion, my exponent will be a billion compared to 2, or a billion compared to 1. So sequence C is going to win for sure. It might start off lower and slower and take longer to get there. You can see it was in last place for the longest time. But eventually it's definitely going to pass these, and it's definitely going to pass them by a lot as more as time goes. And again, I hope you see why that exponent could be a much bigger number than 2 or 1. Whereas these exponents will always be 1 or 2. All right, let's go ahead and wrap this lesson up. Again, I'm not sure if you really got that lesson or that point. Feel free to reach out and ask questions if you have any based on that. I know it's a little bit confusing. But which grows the most? Again, the exponentially equation will, because it is to the x power. Contain more money than a linearly growing bank account for the same amount of time, no matter how steep. Use the. Okay, how does the growth in sequence B compare to exponential growth? And again, B isn't as fast either. Exponential growth will eventually win on both of those.